The IPCC and their climate scientists well understand that many physical, chemical and biological interaction processes occur among the many various components of the climate system on a wide range of space and time scales. This makes the system extremely complex. So complex it is in fact chaotic. The IPCC adds that the climate system is a coupled, non-linear, chaotic system, and therefore the long-term prediction of future climate states is not possible. But working through the chaos, nature quite often brings a balance. For example, sometimes global temperature goes up, and sometimes global temperature goes down. Such a natural balancing act may well be occurring now, as global average temperature is dropping at a faster rate than it rose over the previous century. To put this into a solid context and to understand how this really is nothing unusual, it will help to review the history of global temperature very briefly. This chart shows global mean annual temperatures from 500 million years ago to roughly the present in degrees Celsius. At around 500 million years ago, global temperature stood at approximately 28 degrees Celsius. Ever since, it has gone through natural cycles of rise in temperature and fall in temperature, but overall gradually dropping until the intensely cold period of the Karoo Ice Age. Following the 100 million year Karoo Ice Age, global temperature increased quite sharply, but would fall again under the chaotic influence of the coupled non-linear climate system. Eventually, the global temperature would drop to its roughly present level, which is around 13.7 degrees Celsius, 57 degrees Fahrenheit. Historically, therefore, our current global temperature is very low. It is the lowest it has been for about 260 million years. In fact, the Earth's current climate is the latest stage in a slow cooling process that has been in progress for the last approximately 50 million years. During this cooling, ice sheets formed on the Antarctic continent about 40 million years ago, while the first signs of northern hemisphere glaciation appeared much more recently. And over the course of that 50 million years, many physical, chemical and biological interaction processes of the climate system converged to form the Quaternary Ice Age 2.58 million years ago. Our planet Earth is still in that ice age. At the start of the Quaternary period, there appeared alternations between cold glacial periods with ice on the northern hemisphere continents and warmer intervals with little or no northern hemisphere continental ice. Around 800,000 years ago, weaker cycles with a period of around 40,000 years gave way to stronger, greater isotopic amplitude cycles with a recurrence period closer to 100,000 years, as can be seen from this chart. The period of around 100,000 years aligns with one of nature's chaotic influences, the Milankovitch cycles of eccentricity. The cycles alternated between cold glacial periods with ice on the northern hemisphere continents and warmer interglacial periods with little or no northern hemisphere continental ice. The Earth is in an interglacial period now. This means that the northern hemisphere continental ice sheets and glaciers will wax and wane. sometimes shrinking, sometimes expanding. Peak temperatures in the most recent warm interglacials were 2 degrees to 4.5 degrees Celsius higher than the last millennium. It must also be noted that as well as these long-term peaks and troughs of global temperature, there were much shorter-term variations within each cycle. If we look at the previous interglacial peak at around 128,000 years ago, we see at that time East Antarctic ice cores record early peak temperatures approximately 5 degrees Celsius above the present, and high latitude surface temperature averaged over several thousand years was at least 2 degrees Celsius warmer than present. But during those peaks lasting thousands of years, there were persistent short-term fluctuations in global temperature, as demonstrated by this chart of 127 to 130,000 years ago. After the peak temperature of this period, the global temperature plunged. It reached the lowest temperature of the past 800,000 years, with the last glacial maximum around 27,000 to 19,000 years ago. Ice sheets formed around the world, making the lands they covered uninhabitable, not only on the extremes of the Antarctic and Greenland, but also on the Laurentine ice sheet of North America, the Patagonian ice sheet of South America, and the Eurasian ice sheet. On several occasions, the climate varied from that of the average of the last 1,000 years by minus 10 degrees Celsius, and as can be clearly seen throughout these 8,000 years of extreme cold, global temperature continuously waxed and waned under the pressures of the Earth's coupled, nonlinear, chaotic climate system. But at the same time, a natural balance can be observed. Eventually, the global temperature warmed once again, and the ice sheets retreated. But even this warming process came to an abrupt halt as global temperature dropped sharply for a period of around 1,000 years, the period known as the Younger Dryas. Warming began once more, and this warming phase that took place about 11,500 years ago at the end of the Younger Dryas was very abrupt, and central Greenland temperature increased by 7 degrees Celsius or more in a few decades. After which our present interglacial period, the Holocene, began around 11,500 years ago. Not wishing to be irksome, but again, we must emphasize that interglacial periods are defined as periods with little or no northern hemisphere continental ice, where ice caps shrink and expand during warmer periods. Moving on, this chart shows Holocene global mean surface temperature anomalies from around 10,000 BCE to 1850 CE. We pick up the story at around 8,000 BCE, at which point the African humid period had started. Heavy rain led to the Sahara being reoccupied by human beings, animals and plants as it grew ever greener. As the reoccupation increased, the Neolithic Revolution took place, where previously small nomadic bands of hunter-gatherers took advantage of the fertile lands and transitioned to larger agricultural settlements and early civilization. According to this study by Kaufman et al., published in 2020, at around 6,500 years ago, 4,500 BCE, GMST was approximately 0.7 degrees Celsius warmer than the 19th century. An earlier IPCC report came to a similar conclusion when it declared that summer temperatures in high northern latitudes were around 3 to 4 degrees Celsius above modern values between 9,000 and 5,000 years ago. But a point to emphasize, because a chart such as this covers thousands of years, it smooths out and thus hides the sharp waxing and waning of global temperature over shorter periods, reducing the focus to the still long period of 1,000 years. Fluctuations in global temperature are clearly visible. But after that time of the global thermal maximum, the climate changed again, and GMST cooled at an average rate of minus 0.08 degrees Celsius per 1,000 years. The decrease in global average temperature terminated the African humid period, and the Sahara became ever more arid as the temperatures dropped. Global mean surface temperature continued to drop until we reached the year 1850, which is the start point from which the IPCC uses to measure global temperature anomalies. It is very revealing to look at global temperature over the 60 years following and including 1850. This study from Danish professor Jørgen Petter Stephenson found that at around 1875 we have the lowest temperature in the last 8,000 years. 1875 is midway through the 1850 to 1900 reference start point period used by the IPCC. We can see what happened after 1875 by looking at the modern global temperature data from NOAA. This chart shows global average temperature anomalies from 1880 to 2021. You can see that for around the 30 years following 1880, global temperature actually dropped below that of 1880. In fact, global temperature reached its lowest point during the period 1850 to 1909 at 1900 to 1909. This study by Marcotte et al. Highlights that 1900 to 1909 was cooler than greater than 95% of the entire Holocene period of 11,500 years. This channel is therefore forced to ask, why does the IPCC use the period 1850 to 1900 as its start reference point for the measurement of global warming? For the avoidance of doubt, the IPCC defines global warming as the estimated increase in GMST expressed relative to pre-industrial levels, and the reference period 1850 to 1900 is used to approximate pre-industrial GMST. This is a typical use of that definition. In its latest 2021 The Physical Science Basis report, the IPCC claims the likely range of total human-caused global surface temperature increase from 1850 to 1900 to 2010 to 2019, a 10-year period, is 0.8 degrees Celsius to 1.3 degrees Celsius, with a best estimate of 1.07 degrees Celsius. Or, to paraphrase, the likely range of total human-caused global surface temperature increase from the coldest time of the past 10,000 years is about 1 degree Celsius. Professor Stephenson sums it up nicely. I agree, he says, completely, that we have had a global temperature increase in the 20th century. But an increase from what? It is probably an increase from the lowest point we have had in the last 10,000 years. And this means that it would be very hard indeed to prove whether the increase in temperatures of the 20th century was man-made or it's a natural variation. It would be very hard because we made ourselves an extremely poor experiment. We started to observe meteorology at the coldest spot in the last 10,000 years. These facts force this channel to strongly contend that the use of the reference period 1850 to 1900 by the IPCC is entirely inappropriate and is either incompetent or deceitful. But putting that to one side, we repeat and conclude with this important point made by Professor Stephenson. It would be very hard indeed to prove whether the increase in temperature in the 20th century was man-made or it's a natural variation. The professor's statement connects logically with our opening statements about the balance of nature. Sometimes global temperature goes up and sometimes global temperature goes down. We said that such a chaotic balancing act may well be occurring now. The very modern increase in global average temperature could be balanced by the drop in global average temperature that has occurred since 2015, and the fact that the drop is in fact happening at a faster rate than it rose. This is the NOAA chart 1880 to 2021. Global average temperature has been rising, but since 2015 global average temperature has been dropping. So if we look at the period before 2015, that is 1880 to 2014, global average temperature increased at a rate of 0.68 degrees Celsius per century. But since 2015, it has been decreasing at a rate of 0.91 degrees Celsius per century. So could this be a natural variation, a natural balancing act, as we have seen many, many times before? Just 3 examples. 130,000 years ago to 127,000 years ago, where during a naturally warm period, sometimes global temperature went up and sometimes it went down. Nature exercising a chaotic balance, the same chaotic balance at a period of freezing global temperature, 27,000 years ago to 19,000 years ago, and at another peak of warm temperature, 7,000 years ago to 6,000 years ago. And what is very relevant to the present is that when an interglacial period reaches its peak global temperature, there will come a time when global temperature will fall and rise again chaotically, but eventually the world will slide into a new glacial period. And a new glacial maximum will be reached, where large parts of the world will be covered in ice sheets and uninhabitable. We may be at such a point now where the coupled, non-linear, chaotic climate system and balance of nature bring about a balancing decrease in global average temperature, and the planet returns to a colder climate, but hopefully not too cold. Of course, despite the trend of a drop in global average temperature since 2015, the future state of the climate is not possible to predict. But given what we have learned in this video, some concrete conclusions can be reached. The climate has always changed chaotically and unpredictably. There has never been a good and normal climate. Why is this important? Because the exact opposite of these statements are fundamental to the arguments of climate crisis proponents in the IPCC, World Economic Forum, United Nations, and our governments. For example, at the 2021 COP26 Climate Change Conference, it was stated that the Earth's climate is changing from a good and normal climate to a warmer, abnormal and alarming climate and needs to be restored to its previous state. This statement has absolutely no basis in climate science. Another example from Dr. Catherine Hay-O. The climate has been stable over the course of human history. And now, all of a sudden, that's not the case anymore. This statement demonstrates quite unbelievable ignorance of climate history and climate science. The second major conclusion is that the use by the IPCC of the period 1850 to 1900 as the start reference period from which to measure global warming is entirely inappropriate and unscientific. It means the 20th and 21st century increases in global average temperature are being measured from the coldest point of the past 10,000 years. This community combines the topics of climate change, COVID-19 and the New World Order. If you would like to join our community, you can find us on locals.com. The New World Order. This link will take you directly to our site.